I'll go ahead and post the file from last Thursday first. So that way we have the file online and you guys can at least refer to that. Last Thursday would be the 6th. Is that the 6th or the 5th?
5th.
5th? Okay. Today's the 10th.
Questions on the final are going to be about the same difficulty as that practice.
I get asked that a lot, but I really don't want to answer that question. Not because I don't want to tell you guys, but because my assessment of difficulty is not the same as most students. So I can say it's about the same, and then it turns out to be like completely different. And I got a lot of complaints about that from my cisp300 class. You know, because the students would ask exactly that question. They would look at the practice test and go, okay, is the exam about the same as the practice test? And I would say, yeah, it's going to be about the same. And then it would be a slaughter, right? It'll be a slaughter. And then after the exam, the students will say, you know, oh, man, you said it's about the same difficulty. This is like a whole different order of magnitude. So I'm not going to really say anything, except, you know, the first and the second exam are probably good examples of, you know, how much the practice test will be different from the actual test. So I can only tell you that much.
So there's going to be 5 questions?
There'll be 5 or 6, you know, questions, you know, depending on the difficulty. Probably around 5. The good thing about more questions is if you feel one question is going to take too long or it's more difficult, you can move on to the next one, and the impact of not answering one question will be less than if we have fewer questions. So it's kind of like a trade-off, you know, between having more questions and fewer questions. It's more likely to be like just 5 questions, you know, because we don't really have that much more time compared to our usual exam. So 1 more question is just about right. I was trying to upload the zip file for this class on Thursday, so let's do that first. File. Oh, I put it in the wrong place. Here. The link. Say return to course. Now it's all done. How about the video clip? Did I upload the video on last Thursday? So that was not uploaded either? Freshest smelling commercial on earth. Somehow that does not appeal to me.
It's supposed to.
I think neutral would be good. Okay, so I'm uploading the file at the same time. Here we go. All right. So what do you guys want me to do? Do you want me to kind of go over those questions, the solutions for that we talked about on last Thursday, or do you want me to kind of talk about something different?
What solutions refer to?
Or I can just replay the video from last Thursday. I mean, you know, do you guys feel there's any particular question about the topics that we have talked about so far? I would say the return value thing, passing by reference, you know, that sort of thing, you know, can be a little bit tricky. And also, how do we combined the concepts of passing by reference with array indexing as well. So are there any questions about the combination of those 2 concepts? Yep.
I don't really have a specific question, but I guess I'd like to see a little more review of the pre and post conditions if we could.
Okay, pre and post conditions. Okay. Any other? No. Okay. So you guys want to deal with pre and post conditions a little bit more? Okay. We can do that. So specifically, do you want to use just assignment statements, or do you want to combine that with conditional statements? Because I think it's the conditional statement that makes it more tricky.
Yeah, I think it's the conditional statement.
Okay, well, let's deal with conditional statements. So let's go ahead and start with line 1. If x equals, okay. So this one is actually less complicated than the one we have in the class. And we'll go with a forward derivation first, and then we'll go back to a backward derivation and see if we can actually do anything about the backward part. Okay. Or do you guys want to go start with the backward first? Because I think the backward is the more difficult part. Yep.
If you do this and you say, okay, here's pre-1, we would go all the way to find what post 5 was. We wouldn't have to go back and try and trace it again going backward? Or would we only have to, if you gave us the post, would we only trace it backwards and then go forward?
Well, if I give you the post, in this case, if I give you post 5, then you will have to use your own method. Whatever method you choose to use is fine, but you have to use your own method to get back to pre-1, and then you have to go forward to prove that your pre-1 is correct. So that's what you have to do when you have to go backward first. So I don't need you to explain how you go backwards step by step, but you do have to go forward again step by step using your own precondition for the entire thing. Okay, so let's go ahead and look at this one, and let's just say that the postcondition of line 5 is y equals 5 and x equals 10. Okay, so let's just say that that is the postcondition. When the program stopped execution, this is what I know for sure. So the question now is, can I push this? How much can I push it back to get back to pre-1? That's the question. Okay, now this one is a little bit tricky because only one branch will work, the other branch cannot work. So let's figure out. Yeah, go ahead.
Okay, if we know it won't work, do we have to still show that, or can we just say it, or do we have to show that it won't work and why?
You don't have to do that because remember what I said. If I give you the post condition first and you're moving backwards, you can use your own method to go backwards. I'm not going to assign any point values of going backwards. But whatever you have as a precondition, you have then to move forward and try to come to the same post condition that we have here. Okay, so it's good and bad. It's good in a way that you don't have to conform to a particular way of going backwards, because we have not talked about a very standardized way to going back. Although we have standardized ways of going forward, but that also means that if you make a mistake going backwards and your precondition is wrong, then the point values will change because it is possible that you cannot really go forward and get to the same conclusion.
Right.
Yep. Okay, so let's start with this one. If the post condition of line 5 is like this, we can probably do something about post 4, right? Because post 4, between post 5 and post 4, nothing can have happened, which basically means in post 4 we have about the same condition here. So we can say post 4 equals post 5, and that translates to y equals 5 and x equals 10. Now we can do the same thing with post 2. Now some people can say, no, we cannot do this with post 2, but let's go ahead and do this with post 2 as well, because nothing can have changed between line 2 and line 5. After line 2, after this assignment statement, nothing can have happened. Okay? So right now it doesn't make any sense. Okay? You can see that it does not make any sense because I'm saying that post 2 is y equals 5 and x equals 10. It doesn't make sense because if you go forward, then you will see that your line 2 would have changed the value of y to 4, and therefore it cannot be a value of 5. But let's just say that this is what we can do just by pushing it backwards. Okay, if I know what is post 4, can I derive what is pre 4? Yep.
Do we also, like in this, thinking this way, wouldn't we also have to say that post 5 and also y is equal to 4?
Not yet, because you can only know that when you're going forward. When you're going backwards, you cannot. Okay, what about pre-for?
Would that be post 2?
Before x equals 10 and x is not equal to z.
Okay, very good. But we cannot say anything about y anymore, can we? Because on line 4, this assignment statement is a one-way street. It will destroy the value of y, and we know that y will have a value of 5 after this point. But there's no way for me to know what was the value of y before line 4. So that's why the pre-for here only has x equals 10 left. However, we also know something else. Because line 4 is also the first line of the else part here, the fact that you're in the else branch means one thing.
False.
What does it mean? It means the condition is false. The condition of the conditional statement is false, which means, technically speaking, you can start with it is not the case that x equals z, but that can easily be simplified to x does not equal to z. So that's pre-4. And now we have to deal with pre-2. Okay? Now for pre-2, you can basically just look at line 2 and just say, it's not possible. Okay? So you can, if you want to, you can just say it is false. Okay? Remember, I don't really care how you go backwards, but in this case, there's no way, you can have a post condition of y equals 5 when you have just executed the statement of y gets 4. So that's why you can say the precondition of line 2 is just false. And if it is false and x equals z, then it really simplifies to false. Because false and anything is false. Yep.
I'm just a little bit confused. When we were, when I asked you about pre-4, you said that you couldn't say, you couldn't talk about y equaling 4 because it's a one-way street. But you also said that you couldn't refer to y at all. So when you say it's a one-way street, do you mean that you're taking only one branch of the conditional, or
No,
that you're only...
a one-way street means you cannot reverse to the value of y before the assignment statement. That's what I meant when I said it's a one-way street.
Oh, okay.
Yep.
So the precondition of 2, we get false because we know that we never got to y as it did before. We know we went to the other branch, so false has to be...
It's conflicting.
Yeah.
It is conflicting because, okay, if I did not do this, I can do it step by step to show why it is false too. Okay, now pre-2 has two things. One is I would have forgotten. Okay, let's do this. Because I would have forgotten, what the value of y was. So I would have forgotten what the y equals 5, because I just changed it to 4. But the operation is not reversible. I cannot get past this hurdle here. Now with the other one, I can get past this hurdle because it is consistent. Okay, the post condition is y equals 5. This one does make sure that y will get a value of 5. So when it's time to reverse the operation, all I can say is, okay, I know that after the operation y is going to have a value of 5, but before I cannot do anything about it. But in this case, I cannot get past it because I know the value of y is 5 after the operation, but not only can I not go back and figure out what was the value of y before line 2, it also is not consistent with the effect of line 2. Yep.
That being the case, wouldn't it be in the post 5 when you put it? Wouldn't that be where you put false, since we know at post 2 that it's not true?
That is correct. But remember, also remember, you can say anything or false, and it is just that anything back. So in other words, you can look at any expression, and you can always say that, oh, it is also the same as blah, 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 or false. And that's why I did not write this part here, because you can take any Boolean expression and always add an or false to it, and preserve the exact meaning of the thing.
I meant in post 2.
In post 2?
Because when you say it's equal to post 5, which is equal to this, but we know since,
we didn't know at that point because we have not examined what line 2 is about.
okay.
But by the time we have to examine what line 2 is about, that's when we first notice that it is conflicting. because line 2 will change y to a value of 4 for sure, and yet we have the post condition saying y equals to 5, and those two are conflicting, and therefore we cannot have it. Any other questions? Yep.
I think for me the confusion comes in that there seems to be a little bit of inconsistency in there's no standard direction that things are moving. We're starting at the bottom and working up, but it's just the difficulty of telling when when should we choose to ignore a condition that we know versus does that make any sense?
If you have an assignment statement and the right-hand side does not refer to the left-hand side, that means the operation is not reversible. Now, if the operation is not reversible, if you have the post condition and you know something about y, in this case, after the operation, there's no way you can know whether that condition is still true before the operation, because there's no way for you to know the value of y before the operation. So that's why you have to apply the basically you have to apply the forget operation, for the post condition to get back to the precondition, because it wipes out the value of y and it's not reversible. Is that okay, or?
I think so, but I just I was wondering in for instance in pre-4, why couldn't we refer in pre-4 to y? Because
because y can be any value. As long as y can be any value, because even this part is not helping. Even though we know for sure that x does not equal to z, it doesn't mention anything about y. So y really can be anything before this point, and and that's why y is not mentioned anywhere as the precondition of line 4, because it really can be anything and still end up with y equals 4 after line 4.
Okay, that makes more sense.
Okay. Yep.
So we know that pre-2 then has to be false because we never, since we got y is updated to 5, we know we never went to line 2, and so for that to be the case, the first line must be false.
That's correct. Because we could not have gone that way. Okay. So now it's technically false, and the precondition itself, the condition of the conditional statement, but false and anything is technically false. So that's why we know that this is basically a dead branch with the post condition that we are getting in this case. So once we know pre-4 and pre-2, then we can merge those two to become pre-1. So pre-1 is just a disjunction of those two. In other words, it is pre-2 or pre-4, because we could have come back through either of those branches. But if you look at pre-2 is false, and then pre-4 is this mess here. And false or anything is just anything. So now the precondition of line 1 is just x equals 10 and x does not equal to z. If you want to, you can say that z does not equal to 10, because we know what x is, we know that x does not equal to z, so we know that z does not equal to 10. But at this point, we don't know anything about y, because there's no way for us to track backwards to figure out the value of y before line 2 or line 4. Is that making any sense? Kind of? Okay. So now, we have to take pre-1 and then go forward again. If you know what is pre-1 and go forward, the first thing you want to do is to deal with pre-2. Okay. Now, when you go forward, you cannot just say that pre-2. You cannot just say that line 2 is a dead branch and not even to figure it out, because we don't know it's a dead branch at this point. So you still have to go, using you have to still use the regular method of saying pre-2 equals pre-1 and the condition of the conditional statement. You still have to say that. But once you apply that, what is pre-1? Pre-1 is x equals 10, and x is different from z, and x equals to z. The first part I cannot really do much about it. X equals to 10 is something that I cannot do much about. But these two I can. Because this is saying that x does not equal to 0, excuse me, x does not equal to z and x equals to z, which is a contradiction. Okay, if these cannot be true at the same time, regardless of the values of x and z, that means this whole part becomes false. Now, if that whole part becomes false, I'm not going to do any simplification here. That means the entire thing has to be false, because anything and false is false. Is that okay? So we still make the conclusion that line 2 is a dead branch, but this time I did not even utilize the fact that when we go backwards, we realize that line 2 is a dead branch. We were just simply using the precondition and come to the same conclusion using the derivation that we have always been using. Okay. Now, just because pre2 is a dead branch doesn't mean that you cannot just apply the forget rule, because you can still apply the forget rule even if the precondition is false. Okay. So we can still say that the right-hand side of line 2 does not refer to the left-hand side. Use the forget rule. You can still do that. Okay, just because it is a dead branch doesn't mean that you cannot apply the forget rule, because you can see what happens when you apply the forget rule. You will see the post2 equals to forget pre2, forget anything that we knew about y, which was nothing, and also at the same time, at this point, y should become 4. Now let's take a look at this part here. Let's go ahead and explain what is pre2. What is pre2? Pre2 is false. We forget everything that we knew about y, and y equals 4. So what is the result of the forget operation?
False.
It's just false, and we are still using a conjunction to end it with y equals 4. Any false and anything is false. So we still come to the same conclusion that post2 is false. Okay? Now that is useful, that is important, because after we merge the entire conditional statement at the end, we still want to take post2 as a component of that. It's just that in this case it's a trivial part because it is false. Now we can also work on what is post4, okay, and apply the same reasoning here. The right-hand side of line 4, the right-hand side of line 4 does not refer to the left-hand side. Use the forget rule again. So this time we can say post4 equals the result after forgetting something about pre4, and we are going to forget everything that we knew about y, but after this point we know that y equals to 5. And what is pre4? Pre4 is this part here, so we'll just copy and paste it. Yep.
Can you use that? Because that's not, you had used that back when you were doing backwards, but haven't gone forward yet with pre4.
Oh, you're right. Yeah, I have not derived it yet. Sorry about that. You're right. Okay, so that means I have to here I have to specify what is pre4 going forward. That's right. I forgot to do that. It is pre1, and it is not the case that x equals to z. So now we have to look at what is pre1. Pre1 is this mess here, and not z, x equals z. So when you look at this part here, we can do some simplification. Because x is different from z is exactly the same saying that x is not, it is not the case that x equals to z. So these two simplify to exactly the same thing. So we still end up with x equals 10, and x is different from z. But you are right, I did not mention how to derive pre4 going forward first. So now we can go here and still use the same thing, except this time, we know that we are using the result from going forward. Forget everything about y in this case, and y equals 5. And since we did not mention anything in the precondition, that means we can preserve everything here and just add the fact that y equals to 5 at this point. Okay. Any questions? Okay. Now that we have post 2 and post 4, we can say something about post 5, because post 5 is really just post 2 or post 5. Post 2, oh sorry, That would be bad, right? Okay, post 2 is false already, we know that. And then post 4 is this bunch here. But false or anything is anything, so that means we only have this much left. And this is our post 5 going forward. So the question now is, if we look at the post 5 going forward, it seems to have more information than the post 5 that we start off with. But is that okay?
Yes.
It's okay because they are not conflicting. As long as they are not conflicting, we are still okay. So are we doing okay with this? With this example? Now, the dead branch here will no longer be a dead branch if I say something like this here. I'm not going to change this. I will just copy and paste it as a new case. So for your, as an exercise, you can try to figure this part out. If I give you the same conclusion, okay, so I will say this part here. This time, the derivation will be really quite different because this time, line 2 is no longer a dead branch. It is possible for y to equal to 5 after line 2 because y just has to be 4 before line 2. So now this time, the precondition of line 1 is going to be different. Do you guys want me to go over this one too? Yeah, okay. So in this case, we know that post 4 is exactly the same thing because we haven't made any changes to line 4. So we can say line 4 is post 4 is post 5, and also at the same time, x is different from z because the condition of the conditional statement has to be false for me to go to the else branch, and this is the first line in the else branch. And so just to be more complete, we have x equals 5 and x equals 10, and x is different from z, which is the same as last time. On the other hand, you can now look at post 2. Post 2 is the same thing as post 5 because we come straight from post 5 to get to this point. Oops, I cannot say this yet because we are looking at the post condition. We can only mention that when we get to the precondition. We cannot mention that in the post condition.
You have to delete it from the one right before it too.
Sorry?
You have to delete it from the one right before it too.
Delete the one before. Oh, right. Okay, so post 2 is exactly the same thing. Y equals 5 and x equals 10. Now what makes the big difference this time is the precondition. Pre 4 is the same as last time. It is it's not post 5 anymore because we cannot say anything about y anymore. We can only say something about x equals 10 and the fact that the condition of the conditional statement has to be false at this time. Does everybody understand why I have to take x is different from y away from post 4, but I can add it back here? Do you understand the differences between Okay, this part here, I cannot mention this part. Okay, I'm just going to do this just so that you know what I'm talking about. I cannot do this because I really don't know anything about y. I don't know whether y is still different from x after it got changed to a value of 5. Well, in this case, we can.
Instead of y.
Oh, yeah. Yep, sorry. Referring to the wrong thing. So in this case, we cannot know anything about, well, I guess we can, as a post condition, but we cannot know that before the condition, before the assignment statement, because when we look at post 4, we did not know the effect of the assignment statement, so we cannot mention that. But we can mention that as a precondition, because the condition of the condition of the conditional statement has to be preserved before we start to execute line 4. So that part is the same. Now what is different this time is pre-2. Okay? Before pre-2 becomes false because it is conflicting with the effect of x, y is getting a value of 4. But this time it does not conflict anymore. Because now we know that after line 2, y has a value of 5. But this operation is reversible now. okay, y gets y plus 1 is reversible. If we know that y equals 5 after this, we know that y equals 4 before that. Is that making any sense? So I'm not even trying to use any substitution rule or anything like that. I'm just saying that, if you know that the operation is only adding 1 to the value of y and it became 5, then we know before the operation it must have a value of 4. So that's why in this case we can say y equals 4 and x equals 10, because we did not do anything about x in this case. And also at the same time, we know the condition of the conditional statement has to be true, because this is before the first statement of the then branch. And this time, because of this, pre-1 gets a bit more complicated than before, because we can come back from pre-2. So pre-2 is one way to contribute to pre-1. We can also come back from line 4, and that becomes the second way of coming back to pre-1. So as a result, pre-1 is just the disjunction of those two. Pre-2 is, is this part, and pre-4 is this part here. Are there any questions about pre-1 in this case? So this time pre-1 gets more complicated because the other branch is not the then branch, or line 2 is not a dead branch anymore, and as a result, the combination makes pre-1 a little bit more complicated. The question now is, can we go forward using only the forward derivations that we know about and come to the same conclusion, or at least a conclusion that does not conflict with the conclusion that we already know? So now we have to go forward again. When you're going forward, pre-2 is pre-1 and the fact that x equals to z, because otherwise we would not be going to line 2. So now this gets a little bit complicated, at least at first, because we have to put this entire thing inside here. Okay, but we can use the distributive law of Boolean algebra to make this simpler. Well, actually, we make it more complicated first, and then it gets simpler. Okay, what is the distributive law of Boolean algebra? Okay, it says something like this: A or B, the whole thing, and C is the same as A and C, or A and B. B and C, which is about the same as the distributive law that you know about arithmetics, except in the case of arithmetics, the OR is an addition and the AND is a multiplication, but it works pretty much the same. So in this case, we have to apply that, which means we take, this whole thing becomes blah 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 or blah blah blah. When you see me separating this into two lines, it's going to be a little bit long. Okay, so we have to take this entire thing here and then take the entire thing here too. And in both cases, we have to use a conjunction inside the parentheses and say and x equals z. And the same thing over here, and x equals z. Okay, that's the application of the distributive law. Now, it seems like we're making things worse because we're making it even longer and more complicated. But we can simplify now. Okay, there's an easy way to simplify. We'll start with the first one. If you look at the first one, even though we have the parentheses, structured in a different way, we know that conjunction is associative, which means you can rearrange the parentheses any way you want, and it will still come out to the same answer. Does everybody know what I mean by associative? Yes? Okay, let me give you just one quick way to refer to that. It's basically saying A and B and the whole thing and C is the same thing as A and then B and C in parentheses. That's the associative law of Boolean logic. But it also works in arithmetics. Okay, because 1 plus 2, the whole thing plus 3, is the same thing as 1 plus open paren 2 plus 3. They are exactly the same thing. It also works on multiplication. So that's how we can just rearrange things a little bit and group these two together first. What do you think is x equals z and x equals z? How does that simplify to? It simplifies to x equals z. So in this case, the first one is simplifying to y equals 4 and x equals 10 and x equals z. Okay, so that becomes the first part of our disjunction. What about the second part? The second part looks kind of more complicated than before, but once again, we can use the associative law and just look at these two particular items and say, well, what do they become? They become false because I cannot find any value for x and y, excuse me, x and z, to make this thing true. So if that is the case, that whole thing just reduces to false. Now, if this is false, it becomes something and false. What is something and false? It is false. Something and anything and false is false. False is like 0 in multiplication. It's like 10 times 0 is 0. Anything times 0 is 0. So in this case, anything and false is false. So that means this entire thing, the one thing on the right hand side of the disjunction, just becomes false. What is something or false?
Something.
Just that something, okay? Because false is the identity of disjunction. Is that okay? No? Can you guys see the derivation? Okay. All right. So if that is pre-2, what is post-2? Well, first of all, we have to say that the right-hand side of line 2 this time does refer to the left-hand side of line 2. If I define y as y plus 1, what is the inverse function of that? Y minus 1. Since we have an inverse function, we can now use the substitution rule. When we use the substitution rule, the postcondition becomes the result of substitution. We use the precondition. We find out all the references to the variable on the left-hand side, and then we replace each occurrence with f prime applied to y. And then the next step is just going to expand what is pre-2. Pre-2 is this portion here. And f prime applied to y is just y minus 1. So we'll say that. And after you apply the operation, it becomes y minus 1 equals 4, and x equals 10, and x equals z. If you just apply one simplification step, then y becomes 5, x is 10, and x equals z. Any questions about post 2? Now about post 4 is really the same thing as last time, so I can just copy and paste that from last time. First, I have to mention what is pre-4, basically the same thing as last time. It is pre-1. Excuse me. Shut that off. Okay, so this is pre-1 and the fact that x is different from z, because otherwise I won't be going to the else branch. This time it looks kind of ugly too, because if you look at what is pre-1, pre-1 is one big, complicated thing. So we have about the same thing, except x equals z becomes x is different from z this time. But we can also apply the same thing. We can still apply the distributive law of Boolean algebra, which basically expands it like this, except x equals y is now becoming x is different from y, like that. And then we can apply the same trick again. We can group these two together, and then group these two together. If I group these two together, it becomes false. And since we have a whole big conjunction here, so that means this entire thing is going to reduce to false. The second part is simplified because x is different from z and x is different from z, it's just x is different from z. So now we have x equals 10 and x is different from z. But then we know that false or anything is just that anything. So now we have x equals 10 and x is different from z. That's our pre-for. Post-for, we have to mention that the right-hand side of line 4 does not refer to the left-hand side. Use the forget rule. So now we have to forget everything in pre-for that mentions y. But after this, we know y has to be the same as 5 because that's what the assignment is going to do. And you just have to expand that. And that's what we end up with. Are we doing okay with this part here? Now when we get to post 5, post 5 is still post 2 or post 4. So we'll go ahead and deal with those two. Post 2 is this part, and post 4 is this part here. So now the question is, this seems to be saying a little bit more than our precondition to start off with. Our precondition to start off with is this part, and we ended up with this one here. Are they conflicting? Can one be true but not the other one? One can be true but not the other one. The question is, can this be true but this not be true? That's the conflicting part. No. Because what you need to do is you can rearrange things to make that really visible. So I'll just kind of go through that extra step to make sure that we can easily tell that it is not conflicting. So let me go back to here. Y equals 5 goes first. Y equals 5, x equals 10. And I'm going to intentionally put parentheses that I really do not need around this one, so that we can pick out this item in the second step. Now when we look at the second one, can we rearrange to put x equals 5 first? Because x equals 5 was the last item in the second part of the disjunction. Can I move this all the way up here?
Yes.
And that's because of which rule of algebra? It's the commutative property, right? A plus b equals b plus a is commutative. So we just have to apply commutative a few times to swap it all the way to the beginning. And for the same reason, I can move x equals 10 to the second place. And using the associative law, I can rearrange the parentheses any way I want. And now we have x is different from z here. Okay. This is interesting because how do I simplify this mess here? Which rule do I use to simplify this?
Distributive.
The distributive, exactly. It's the other way around. We are starting off. Okay, this is basically saying we have a. Okay, let me separate this. We are starting with a or b, and oops, the other way. We have a and b, or should not just be here. Let's put this. B is fine. A and C. Okay, we're starting off with this. Basically A is this part, B is this part, and then we have A again because this part is exactly the same as this part here. And then we have something that is different, which is our C here. Now, doesn't that look a little bit like this one here? I use different letters, but you can see the similarity. So now we can simplify this one to what?
Y equals 5 and
A and B or C. Okay? So if that pattern is holding out, what is our A here? Our A is y equals 5 and x equals 10. Right? And we extracted that part out of the inside parentheses and make it the common part of the conjunction. What is our B? Our B is x equals z. And what is our C? X does not equal to z. Okay, now that's interesting because we have one more step that we can do simplification. What is this? What is it? Can we simplify this to something else?
Sure.
Okay, which one?
True.
It simplifies to true because regardless of what is the value of x and what the value of z is, x equals z or x is different from z has to be true. Okay, because x equals z and x is different from z are complementary. They are opposite of each other. So if you have a disjunction of opposite ends, then it becomes true because we are now covering all the possible cases. So if I want to go through exactly, go through this one, step by step, that means this part here, this entire second part of the outer disjunction becomes true. What is something and true?
Something.
Just that something. So now we get back exactly what we started off with, which is a good feeling. It's a good feeling to be able to move backward and then use all the formal steps that we know to go forward again and come to exactly the same conclusion as before. Okay, any questions? I think I'm going to change the curriculum for this class to include Boolean algebra topics. Well, just because it is very useful. I don't want to do that for this exam, so I will make sure that you don't need to understand that much about Boolean expression in order to answer the questions this time. But I think for this class, just being able to reduce something that looks like this into something that looks like this is going to be helpful. So are there any questions about the second example of pre and post conditions? No questions? So easy schneezy stuff?
So we're looking at you do it.
It's until we're actually doing it. It's just
There'll be one question about pre and post conditions, so it's not going to be that many questions.
Well, if it's out of 5, it's 20%.
If it's out of 5, it's 20%,
So
yes.
if you don't know, you're not going to get an A.
Well, just for the final exam, yes.
So you're not going to get an A if you don't know this part.
Or if you completely screw it up.
And that means you get the other 4 perfectly right, the traces, and you don't know this at all. That's what it is.
But you know what? If you give me this part here, you get partial credit already because I know that you can go from the structure of a conditional statement and get to the part and say that, oh, okay, the conclusion is going to be this much here. If you expand and be consistent with your own pre-post 2 and your own post 4, you get the other credit. The rest, which is the simplification steps, I'm not going to, it's not needed to get the points.
Oh, okay.
So that makes it, I think it's really hard not to get, at least partial credit for something like this because all you have to do is to remember what to do about the structure of a conditional statement and you get partial credit already.
Will notes be allowed in final? Notes allowed in final?
Yeah, open book, open notes. If we're doing in the lab, which I have to confirm again, sometime before Thursday.
Okay, so yeah, that was my next question.
You can assume that we are going to be in the lab. If I tell you otherwise, then we have to come back here.
Okay.
Yep.
So you would let us know like tomorrow?
Yeah.
Okay.
Yeah. Well, if you don't receive anything from me, it is going to be in the lab.
Okay.
Yep.
And will it be open early so we can get there at like 9:30, 9:45, something like that?
Yeah, you can be there a little bit early. I'm not sure when they will kick people out of Section C because more likely than not they will use Section C for us.
Yeah.
So it depends on when they start to kick people out of Section C. being the first day of final exams on Thursday, there might be still some people in the lab, doing homework assignments. So when you get into the lab, there may be other people in section C already. Just find some empty spots, and start to sit down. The lab techs will, recognize, oh, okay, it's text class, taking the final exam, and then they will, start to, move people over to the other sections.
Is it 10 or 10:15?
It is 10:15. The exam starts at 10:15 and ends at 12:15. Yep. And once again, I don't want people to be listening to iPods, because I just don't want to, have the thing connected to an iPod. If you think that the surrounding may be a little bit distracting, like people talking, chatting, doing homework assignments and whatnot, my recommendation is to get earplugs. Just go to Harbor Freight, spend $3 and pick up a big ear muff thing. They work really well against even lawn mowers. So I would say that lab they should work extremely well. Yep.
What if we're watching YouTube videos on
Oh.
class?
You can hook it up to the computer.
Okay.
Yep. Just not your own phone or the iPod. Yep. Yep.
So on the
Don't
test,
like that.
on the pre-post conditions on the test, we can get
I forgot about the notes. I was
Yeah.
like, this guy's gonna watch
So we have to go backwards and prove it.
Yeah, you have to go backward, but remember the going backward part is not going to be graded, so you can use any way you want to go backwards.
So you don't care about the going backward part, just the going forward?
Exactly. Because I found that it's really hard to grade the going backward part, because we haven't really talked about the formal steps of going backwards. But the going forward part, we have talked about that a lot of times in the class already. So that part is just consistency. I mean, if you okay, let's say that your precondition is wrong to begin with. Okay, so let's say you did not get to this precondition. Okay. Now that means you will get some points dinged because you did not start with the proper precondition. But then every single step has its own partial credit. So that means as long as your pre-2 is consistent with this, and you take whatever was wrong here and you just stick it here, that you will still get the partial credit for pre-2.
Oh, okay.
In other words, you only get dinged. You only lose points once. The same mistake will not cost you points after that one point. Which means it's not as bad as you think. I'm not just going to look at the final result and go like, oh, you mean this is not y equals 5 and x equals 10, no points. Okay, so that makes grading a lot harder because now I have to go through the whole thing and see if all the steps are consistent. Yep.
Just out of curiosity, do you have any idea of when we know what our grades were for the test?
For this test,
Yes.
well, I have once again I have 3 exams to grade, and they're all kind of open-ended like this. I have to turn grades in I think within a week or so it will definitely be in within a week. But at least how many points you'll be getting just based on all the stuff that I have graded already. So you can add up all those points, and that's a guaranteed point value already. So everything else will just bump your grade higher, but it won't bump your grade any lower than that. Yep.
Have the homeworks been graded?
I don't think they're all graded. I've graded some of them.
Are you
but
going to
not
grade
all
them,
of
or you're just...
Oh no, they will all be graded before I enter the actual final grade. Yes, yes. I would not leave anything that is ungraded and just okay, we'll just leave it alone
Just put
and
it
not grade it.
Yeah, you could just give out some A's willy-nilly.
Yeah.
But the class is actually doing fairly well. I mean, if you look at the distribution of A, B, C, D, F, most people, or a lot of people, are getting A's in this class already. Well, based on their current, performance, they should be getting A's.
And an A is 87%?
A is 87.5% or more.
And a B is...
A B is from 62.5% to up to, but excluding 87.5%. Approximately, Moodle cannot deal with 0.5%, so I just have 87% as the starting point of an A. So that's like 0.5% difference. Any other questions?
You're gonna have a fun week?
Hmm?
You're gonna have a fun week?
I'm gonna have a fun week grading, yes. And I can only do grading at night too, because during the day I have I have to watch the kids, pick up, drop off, and all that stuff.
during the night you have your favorite neighbor who plays music at 3 in the morning.
No, not anymore. That's in my graduate student years. Okay, any other questions? I mean, if you don't have any more questions, I can show you, the C equivalence of the pseudocode that we have been using or talking about this whole semester, which I think can be, interesting. Does anyone want to look at C code? Yeah. Okay. Question or just agreement? Okay. All right. Let's go ahead and take a look at some C code. And I don't want to just show you the C code. I also want to show you how to get C programs to work. So in this case, I'm going to I did not use the proper name.
Isn't it recording the video there?
Yeah, the recording is going to work. This is just the folder, so this won't impact the recorder.
Isn't it recording into that folder?
No.
Oh.
The recording goes into its own file, and then this folder is only for the files that we capture for this class. Nope. Okay. So let's start with something that we are very, very familiar with. Okay, so we'll go ahead and start max 3. Okay. And what I will do is first bump up the font size. The editor that I'm using is called VI. VI is actually the abbreviation of visual. Okay, and to you guys, it makes no sense to call a screen editor or the full screen text editor, visual. But to me, it makes sense because in the good old days, we don't have full screen editors like this. We have what we call line editors. In other words, you can only edit one line at a time. There's no way to move the cursor up and down. So you tell the editor, I want to edit line 216. Okay, it will show you line 216, and there's a command to copy the line over, and then you can make some changes, and then you just press the Enter key to confirm, yes, this is how I want to change line 216. Okay, and that's why VI is called VI, because it was a big step forward at the time, going from line editors to full screen editors.
So in those times, could you see all of the code, or see as much as the screen could hold, but just only edit one? Or
you can list, but you have to type a command to say list line blah 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 to line blah blah blah. Then you can see those lines right next to each other. But it works really well, with a typewriter too, because we had those teletype terminals, so you can only see one line at a time because the whole thing is hooked up to a typewriter, a fancy typewriter as a terminal.
Print it, or
yeah. Yeah, the good old days. Okay, so we'll go ahead and write this subroutine here. Okay, so I will start with comments in C first. Now in this class, because we are using pseudocode, we don't have a concept of comments other than in a trace. When you write programs in C, you don't want to just be able to write C code. Sometimes you want to add your own comments to your whole program and say, okay, this is what this program is supposed to do. This is what this line is supposed to do, and so on and so forth. In C and C++, if you start something with a slash and then the asterisk symbol, it means the beginning of comments. When you see asterisk and slash, it means the end of comment. Everything in between will be completely ignored by the compiler. In other words, it is impossible to make syntax errors in between the comments symbols. Okay, so now I can write the entire program in pseudocode first, and then we'll go ahead and implement this thing in C. So I will define a subroutine. Let's call it max 3, and we'll say that it takes 3 parameters. In this case, we'll just say by val x as an integer. We'll say by val y as an integer, by val z as an integer. We can do the same thing as we usually do. We can say if x is less than or equal to y, and x is less than or equal to z. Oh, we're finding the maximum, so we have to change the comparison. Then in this case, we know x is the maximum. So we can just say return here and just say that the return value of max 3 is going to be x because we just confirmed that x is the maximum of the 3. Then we can have an else if. y is greater than or equal to x, and y is greater than or equal to z, then we just confirmed that y is the maximum. We can say return y. The last case, I don't even need a condition because if x and y are not the maximum, then z has got to be the maximum. And if, and define sub. So we want to take a look at this subroutine that is now written in pseudocode and see how we can translate that into C code. Now in C code, it will look very different. First, you start with int max 3. I will explain what it means a little bit later. Okay, y int c. Okay, so this part here is basically taking the part of everything. This part. In C, you have to first. Okay, the convention of C is a lot of times opposite to what we do in this class in pseudocode. In C, you start with the type of something, and then you say what it is. So in this case, you say int, and then you say x, which is basically saying x is an integer. You say max 3 before, after you specify int, and that's basically saying max 3 as a subroutine is going to return an integer value. So remember that in C, everything is kind of like opposite or backwards. So this is the same thing as what the highlighted portion of our pseudocode is. This portion here. And then in C, we don't say begin something and end something. You just use curly braces to mark the beginning of something, and then use an end curly brace to mark the end of the same construct. Okay, so we don't see while and end while. We just use the curly braces to mark the beginning and the end of a block. Yep.
You said that when you're defining the subroutine, you use the type.
Right.
But I remember we did like a subroutine a couple of weeks back where it just printed a value and it didn't return anything. So what would you do in that case to start the subroutine?
You mean in exam 2, there's one question where the subroutine has a return in some places and not have a return in other places.
Well, basically, if it's a subroutine, it isn't returning a value, but it's just performing an action.
Okay, in those cases, you still have to specify a quote-unquote return type. It's just the return type is called a void, V-O-I-D, void, in that case. So when you say void something, that means there's no type associated with it, which in other words is the subroutine does not return anything. Okay, but in this case, we do have some return statements, so we have to specify the type of the return value. So now we just have to translate the conditional statement. Now in C, when you have a conditional statement, the whole condition must be enclosed in parentheses. If you do not do that, okay, let me make a mistake here. So I'll just copy the code. In pseudocode, we don't really need the outer parentheses. Okay, so in pseudocode that's just fine. But in C code, this is not fine anymore. So let me just do this. Now, we also do not use the word and to mean and, so I'll go ahead and write it the way it is and let the compiler complain about it. Okay. So right now, I have just written a portion that is not really useful. Okay. I just confirmed that x is the maximum, and I have made a whole bunch of syntax errors already at this point. Okay. Remember what a syntax error is? A syntax error is quote-unquote a grammatical mistake. Which includes the use of the missing punctuations, wrong punctuations, incorrect placement of stuff, and let me make one more mistake, okay, just to show you how picky the C compiler is. Okay, so I'm just basically copying and pasting from my conditional statement here. I have not dealt with the else if part. But I just want to show you at least this much here, and then go through the compiler and show you what the compiler is going to say when it sees something that is closely resembling what we do in pseudocode, but we want the C compiler to deal with it in this case. Okay, so I have just exited from the editor. It is time for the compiler to convert that code into the executable. In other words, when you write programs in C, the processor has no idea of how to deal with a program like this. Okay, you cannot feed this program to the processor like the Pentium processor or the Athlon processor and say, hey, Pentium processor, go ahead and execute this program, because this makes sense to us, as a text file, it makes absolutely no sense to the Pentium processor. The processor can only execute instructions that are binary coded, okay, a whole bunch of zeros and ones to specify a very, very small amount of instructions. And we cannot deal with those types of instructions natively, and that's why we write programs like this. So what that means is we need a translator to translate what we just saw in the text editor into a form that the processor can understand. And that translator is called a compiler. In this case, I'm using GCC or the GNU C compiler to compile the program. These are the options. Typically you don't have to deal with the options when you take a class in C, because a lot of times they use an IDE or integrated development environment. Okay, that's what IDE stands for. And when you use an IDE, you can just click on the menu item, and it will do this whole thing automatically. But I'm used to command line interface, and so I will do this. Okay, it seems like it's just complaining one little error here. Okay, it complains about expected semicolon before then on line 18. So let's go back to this program, go to line 18, and okay, let me explain what the error is. The error is the word then is not used in C. Okay, I used the word then in pseudocode simply because that's kind of more conventional. Okay, when we say something, we use if blah blah blah, then blah blah blah. But in C, you do not use the word then. Okay, so let's see if that fixes the problem. Okay, now this time it complains, but this time it complains about something else. Expected semicolon before the curly brace token. On line 19 this time. Now this is really bad because the error is actually on the previous line. Except the compiler complains about the line that is after the problem. The problem here is the parentheses, the condition of a conditional statement must be completely enclosed by parentheses. Now, if you look at the grouping of the parentheses, the outer pair of parentheses really do not add any value to the expression itself. But it is important because C is expecting that particular pair of parentheses. Okay, so let's go ahead and ask the compiler and see if there's any problem here. Well, it's complaining again, and this time it's complaining about line 18. Okay, what about line 18? Line 18 looks fine to us. Well, the C compiler does not understand what is A and D. Okay, A and D spelled out has no meaning to the compiler. If you want to specify the conjunction operator, you have to specify it as ampersand, ampersand. Now this is not a typo. I really meant double ampersand here. If you use a single ampersand, it is kind of like a logical AND, but it's not. Okay, it will work sometimes and not work other times. You have to use double ampersand when you mean logical AND. Are you guys getting a rough idea of what kind of issues you will see in the C class? Just the syntax of that is going to take up some time. It's complaining again, this time on line 21. Let's take a look at line 21. What was the message again? The message was expected semicolon before the end curly brace token. And this time the error message is right on, okay? Because every single statement needs to be terminated by a semicolon. If you miss that one semicolon, which makes very little difference to you or I, it makes all the difference to the compiler. The compiler will just refuse to do the translation. Okay? So let's see whether it compiles this time. And it's complaining about the linking part here. I have no idea why it's complaining about that part.
Can you not?
Yeah, that part I don't really understand why it's complaining. Let me see if I have any.
Doesn't C require you to import the header for, like, at least like a standard?
Oh, I know why it's complaining, because I don't have main
Yeah,
here.
yeah.
Okay? Because in pseudocode, we start execution on the first line that is not inside any subroutine. But in C, every statement has to be inside a subroutine. So we don't have the whole concept of oh, this is the first line that is outside of the definition of a subroutine because everything has to be in a subroutine. So how do we get the program started if everything is in a subroutine? Well, there's a special subroutine. The special subroutine is called main, and this is one way to define main. In other words, implicitly the program or the system is calling main without letting you know. Okay, there's no explicit invocation of main. It's just that it is implied that when you run a program, it will start execution with the subroutine called main. Now we use a particular name for a particular subroutine to start execution. Do you guys remember what the name of that subroutine is for this class? Stub, exactly. So main is basically our stub in C. Okay. All right, so we have a main here. And main has to return a value. Okay, don't ask me why, because it's kind of beyond the scope of this class, but it has to return a value. We have max3 already defined here. The question now is, how do we print out the result of max3? How do we invoke max3 to begin with? Okay, so let's make this a little bit easier. We'll define a local variable first. We'll define a local variable. We'll just call it max. Okay. So once again, it does not say local. Okay, in C, there's no such thing as local because parameters are inside the name, the parentheses next to the name of the subroutine. That's where all the parameters go to. Anything that is inside a subroutine, and if you say max is an integer, it is automatically a local variable. Okay, so in this case, I have max as a local variable of main. And I want max to become the result of the invocation of max3. So now you have to say max3, and here I can say, let's find the maximum of 23, 7, and 19. Okay, this is how you call a subroutine in C. It is a lot simpler and a lot cleaner than the way we do it in this class. There's no such thing as 23 goes to X, 7 goes to Y, and 19 goes to Z, because everything is done by position. Okay? X is the first parameter, so 23 as an argument is going to go to X. Y is the second parameter, 7 is going to Y. And Z being the last parameter, 19 is going to Z. So that is all implicit. It's all done by ordering of the parameters. Now, on one hand, this is really nice because your program is a whole lot shorter with this convention. But what is the problem, or one potential problem of this?
You can mess up the order.
You can mess up the order. Now, in this case, it doesn't matter because if you're trying to find the maximum of 3 numbers, any order is fine. But if you're not doing something like this, where the order of the operand or the order of the parameter is important, there's no double checking. It is not clear. When you invoke a subroutine, this part here, it doesn't say what 23 is specifying at all. But in the pseudocode that we do in this class, it does specify 23 goes to this particular parameter. Okay? And then the other thing is there's no such thing as invoke. If you mention the name of a subroutine, it is automatically an invocation. So in this case, we are invoking max3, using 23 to specify parameter X, 7 to specify parameter Y, 19 to specify parameter Z. And then the other part that is confusing is there's no left arrow either. We use a single equal symbol to mean assignment. So in this case, whatever max3 returns, we want to put that into max as a local variable. So you can see that syntactically speaking, there's a big difference between the pseudocode that we talked about in this class and the actual C code. The next part is how do we print it out? Okay, in this class, in pseudocode, we just say print max, and it will print out the value in max. But in C, it is a little bit different. This is something that you won't see in your C++ class either. This is kind of like a C only thing, and I'm not going to explain this one. It's just a little bit cryptic. And it's not worth explaining because you won't see it. You will see, the C++ implementation of this thing and not the C implementation of this thing. But basically, this is how you print out the value of max as a decimal number. That's the end of this program. Let's see if it works. No. Okay. This is the other part. You have to use a include file, pound include, to include some definitions. The professor of the C class will explain what that means. But it's just one of the things that you have to do. And we can now try to compile to the executable and run the program, and it prints out 23 because that's the expected output of the program. Okay. Just one more thing. This one is going to be important because if we use a single equal symbol to mean assignment, what do we use to specify compare to see if two things are exactly the same? It's a double equal, exactly. So that means if I want to see if the maximum is actually 23, this is what I have to do. I have to say if max equals 23, then we can do something here. The answer is really 23. Okay. 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 And this time the output is the answer is really 23 because maximum is 23 of those three numbers. Now here's the fun part. This is the really, really fun part of this. What do you think the program will print this time?
Error.
It will print nothing, right? Because there's no else corresponding to the conditional statement, so there's nothing to do when the maximum is not 23. Okay, that's the correct behavior of this program. So we'll go ahead and recompile the program and run the program again, and sure enough, it does not give me any output, which is correct. What if I make a mistake and say that since I forgot that to compare I have to use double equal, and instead of using a double equal, I use a single equal. It will still go. This is equivalent, okay, in our pseudocode equivalence. This is equivalent of using a left arrow inside a conditional statement, which makes no sense in this class because an assignment operation is its own statement in this class, and it makes absolutely no sense to put an assignment statement as the condition of a conditional statement. But guess what? It makes perfect sense in C. Okay, so what happens here is when it evaluates the conditional statement, it will first perform the assignment operation. Whatever max was, which is 19, will now be overwritten with a value of 23. And then you will say, oh, but 23 is not a Boolean value, right? I mean, if it is inside the condition of a conditional statement, it has to be a Boolean value. But in C, there's also no such thing as a Boolean value. Okay, you can use just about anything as the condition of a conditional statement. Now, if I use an integer here, how do I know whether it's true or false, whether to execute the then or the else part? If it is 0, it is false. If it is anything but 0, it is true. So 23 is considered true, and as a result, it will print the message. So let's go ahead and finish this last part here, because this shows you all the trouble that you will see in the next class. Okay, just by missing one equal symbol, the program is now completely incorrect. Okay, it's not just for this line because it really changed the value of max to 23. So the rest of the program, if it depends on max, they will also be wrong from this point on.
And then you change something else, and then you're all just in
all sorts of pain. So that's the kind of stuff that you can look forward to in CISP 360. And by the way, there's no